Okay, next up, we like to compare N2H4 to N2H2 and determine which one has a stronger nitrogen to nitrogen bond and which has a stronger and shorter nitrogen to nitrogen bond. And so this is going to be similar to the question we did before, where we determine the bond order by drawing the Lewis structure, and then that bond order will tell us both about the length and energy or strength of the bond between the two nitrogens. So for N2H4, we have 10 electrons from the nitrogen plus 4 electrons from the hydrogen, so that's 14. We had drawn it out before. If you double check on both your valence electrons, you should have 2, 4, 6, 8, 10, 12, 14. So valence electrons check out. Formal charges on each of the nitrogens, you'll get 5, minus 2, minus 3. 0 as expected. On each of the hydrogens, you'll get 1, minus 1, 0 as expected. So this is definitely the correct Lewis structure. Next up, let's move to N2H2. That would be 10 plus 2. So 12 electrons to work with. So we'll have N, H, 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 H. If you have a single bond between them, then it would leave us with 2 electrons on each. Sorry, there's only 2 hydrogens. N, H, H. So let's say we filled in everybody's octet. We get 2, 4, 6, 8, 10, 12, 14. Too many electrons. And so we deal with that by including any double bonds that we can. And now we have 2, 4, 6, 8, 10, 12. These are taken care of. Double check on your formal charge. And you will have on the nitrogens 5, minus 3, minus 2. 0 is expected. On the hydrogens, you'll have 1, minus 1, 0 is expected. So these are your two structures. Now let's check on the bond order on both of them. Because this one is a double bond, its bond order is going to be 2. This one is a single bond, so its bond order is going to be 1. We know that the higher the bond order means the higher the bond energy, which means the lower the bond length. And so let's begin with the topic of bond length. We know that N2H2 has a higher bond order, which means a higher bond energy, which means a shorter bond length. And so N2H2 will have a shorter bond length, described by this relation. And then now we check on bond energy. So the higher the bond energy, the stronger the bond, because that means that there's so much energy in that bond and they're being held together so strongly that it's going to take a lot to break it. And it's taking a lot because there's a lot of energy in that bond, which is described by the bond order. And so again, for N2H2, because it has a higher bond order, it's going to have a higher bond energy and therefore be stronger. And so it'll have the stronger bond. And that's it for this question.